Alright, so today we'll be trying to visualize the Collatz conjecture, right? So we'll be trying to get to what we're at right now, what we're seeing on the screen. Let me rotate this just a little bit, well, less, I guess. It's just for us to see it a little bit better. There we go. So that's the goal of today, getting to this over here. And let me even not translate this at all and see what we get, right? So this is the whole goal today. We're trying to get and visualize the Collatz conjecture, right? So let me get to the whiteboard and explain just what it is. Let me erase this. Over here. Okay, that's good. All right. Yeah, it's fine. All right, so the Collatz conjecture. Collatz conjecture is basically just a way to get to 1, the number 1. So you start with any positive integer, right? So let's say we start with, I don't know, let's say we start with 7, right? Collatz conjecture is just a function of which you pass some positive integer, right? And you basically have, well, you basically have two conditions, right? So if x is even, and if, or otherwise else, or if x is odd, right? All right, so if x is even, you basically just want to return x divided by 2, and when it's odd, you want to do x times 3 plus 1, right? So that's the whole Collatz conjecture, right? So if we start from 7, it's odd. So we need to multiply by 3, 21, and then add 1, so 22. And then 22, it's even. So we divide by 2, right? So we get 11, right? And then 11, it's odd. We multiply by 3, 33, and 33 plus 1, 34, right? So on and so forth, right? So let's just do it real quick. So 34 divided by 2, since it's even. So we get 17, right, yeah. 17 plus 1, 18, sorry. And so on and so forth. And you get to 1 eventually. Well, it's not been proven that for all of the numbers it's getting to 1, but it's been proven up to a certain really high integer. So that's the whole thing. And some people visualize it like, I don't know. Let's take I don't know, 8, for example, 8, right? So 8 goes down to divide by 2 to 4, right? And 4 to 2, and 2 to 1. And you stop at 1 because 1 is odd, and then you would multiply by 3, add 1, it would go back to 4, right? So, and people just visualize it like this, right? Let's say, let's take 5, right? So 5 is in between those, but let's take 5. So 5, start at 5, you go to 15, 16, 16, divide by 2, it gives 8, right? So 16, maybe 16 over here, right? And then you have maybe 5 over here, right? So 5, 16, 8, so on and so forth, right? So you can visualize it pretty much however you want. I'm going to use the one that was mentioned in the Numberphile video. I will link it in the description. I will also link from it Danniel Shifftman video from the coding train, where he tries to also do this visualization. And So basically, the goal is you start from X number, right? And then you start from 0, 0, let's say, or from any given point, and you draw a line from that point to the next number, to the number given from this function, and you angle that line. So you basically either angle it, let's say this is this is the 0th angle, this is maybe like quarter pi, this is also, let's say, quarter pi minus quarter pi, right? So if it's even, you change the angle by, I don't know, a quarter pi. Otherwise, if it's odd, you change the angle by minus quarter pi, and then this is your new 0, 0, or this is, right? And then you do that again. Based on the result, you draw another line either from here or to here, right? And so on and so forth. So that's the whole goal. I'm going to leave the part of drawing the line to you, just because I haven't done it yet, and I don't have the time today. So we'll only draw the specific points where the lines needs to be connected, right? So you can, I'll leave the connecting up to you. So we'll be drawing the points. So that's the whole goal. So let's try and do that. Awesome. Okay, let me remove everything I've done previously. So we need some type of function. Let's create a function which will return an integer. It'll return the next value. So we can call it maybe next, right? And it'll receive x of type int. Should basically do if, and we'll say if x is equal to 1, just return x. Right? Just because let's not keep going when x is 1. It doesn't matter because they all go back to 4 and then 2 and then 1 again, right? So let's just do this like this, right? So if x modulus 2 equals 0, this would mean that it's even. Then we need to, because let's say 4 divided by 2 gives us a whole number, which is, it doesn't matter. It gives us a whole number, so 0 reminder, and so we want to return, we said when it's even, we want to return x divided by 2. And otherwise, or just otherwise, return x times 3 plus 1, right? There you go. So that's the whole Collatz conjecture, how you can achieve it, right? And you start from any given x up until your x is 1. So you call this recursively, or as many times as you're not at 1. All right, so we will start by having maybe, well, let's do our void setup to start with. Awesome. Let's do a size of 600 by 600. We can do it bigger afterwards. Let's just get the first step rolling, right? So we'll get an int, let's call it current. And let's start it at 7, right? Just for now. And we'll say as long as current is not equal to 1, we'll basically say current is equal to next, calling it with current. There you go. And before doing this, let's just print what we get back from this, right? So current. Awesome. Okay, so let's see what we get if we do this. We won't see 1, so I'm going to just copy this and put it here just so that we do see 1 at the end, but it doesn't really matter. All right, so let's start this and let's see what we get here. This is a bit small. I cannot seem to make it bigger. All right, so we can see it here, right? So it's what exactly I wrote to the board. Well, I mean, I wrote 18, but I started by 17 and then wrote 18. I don't know. Anyway, we do get the proper Collatz conjecture for 7, right? And it's a conjecture, but not a proven conjecture, right? The conjecture is that everything will go down to 1. It's only proven up to, I don't know, but a really big integer. I don't know which integer exactly, but supposed to be a pretty big one, like 2 to the power of, I don't know. Anyway, doesn't matter. All right, so we're pretty much done, I have to say. I mean, the Collatz conjecture part is done. Now we need to visualize it, right? So the visualization, right? Let's start by drawing a background, like a dark background. It doesn't need to be black, but a dark background. Let's see it. Okay, great. And now we want to draw a point. So a point, and I'm going to use the translate and rotate function that will basically change the origin point of the canvas to the given and displays this origin point based on the translate and rotate function. All right, awesome. So let's first do push matrix. Anytime I use this, anytime I move the origin point, I like to have it separate from anything else, right? So let me do push matrix and pop matrix over here. Awesome. Okay, and now let's do it. So what we want to do every time is move it, right? So we need to do a line. So we need to move it at from a certain distance at a given angle, right? So we need to rotate by either, let's say, a positive quarter pi or a negative quarter pi, maybe even less than that, right? The angle should be pretty small. And then after rotating that origin point, we need to translate it and move it basically maybe 10 pixels to the right, right? And to the right, I say to the right, but it would be based on whatever rotation we're currently at, right? So let's do maybe, so basically we need to know if the current is odd or even. That's all that we need to know. So again, let's take this formula over here. Well, not really a formula, just checking if it's even or odd. Awesome. And this won't be x, it'll be current. Great. And if it's odd, if it's even, let's say we're going to say quarter pi divided by 4. I don't know. I want a pretty small value to be the angle, right? I really don't want a big angle. Otherwise, it's going to go really off the screen really fast. So let's do this. Let's do this issue. Quarter pi is not defined. Oh, I'm missing the r. Yeah, that makes sense. All right. Let's do quarter pi. There you go. Okay, awesome. There you go. Okay. So let's do also stroke. Stroke white stroke, and let's do stroke weight of, I don't know, maybe 5 for right now. We can always change that. Okay, let's see it. Okay, so we're seeing some dots. That's good. Let's maybe change the number to maybe a bigger number, maybe 49, right? I don't know. Okay, we're seeing stuff. That's good. Okay, now let's try to do multiple of these, right? Multiple current numbers at the same time. Well, not at the same time, but draw them like, let me show you. So let's do like for I is equal int I is equal. So we're basically going to do it multiple times. So I is equal to, I don't know, let's say we start at 3. I think that's a good number, or even 2, right? That's fine. I is less than, let's say we go up to 100. So we're going to do the Collatz conjecture for the first, well, from 2 to 100, right? Starting from those values. So 98 times, right? And we can do equals, that's fine. Okay, awesome. So as long as, well then I plus plus, okay, great. So let's do the whole thing that amount of time. So let's, okay, current. int error on incurrent syntax. Oh yeah, I'm missing curly brace open, and current should be changed to I as well. Let's see this. There you go. So we're pretty much done, I have to say. I might want a even smaller angle, so maybe divide by 6. Maybe also not have them spread out that much. Maybe like move it by 5 instead of 10. Right, so this is the Collatz conjecture. What we could do also, maybe have a low, like a little opacity on this, right? So maybe like 150, right? So we can see it go on top of each other. Maybe we go to 1,000, right? This is going to take a bit more time to process, but there you go, right? I'm going to go down in opacity as well. Oh, and just the fact that we're doing this is also taking up some time, right? So let's do maybe, no, 20 maybe. I don't know. We'll see. There, right? So we're seeing the Collatz conjecture right now. So that's great. And even maybe like maybe spread them even less, maybe 2. We can down the stroke weight to 1 again. And let's try moving everything, like the origin of the whole drawing, to the center of the canvas, right? So translate to width divided by 2 and height divided by 2. Okay, so let's see this, right? Cool. I think maybe this could be a little bit higher, maybe like 50 should be fine. Right, so we can see the thing that we want to see, right? So this is the Collatz conjecture. This is not the greatest drawing you can do of it, but I would suggest taking the sketch and updating it, make it your own. Like I said, these are just points currently. It would be nice to be able to draw lines, maybe shade them different colors, depending on if it's odd or even. You can arrange the lines in a different way. Maybe you don't want it, maybe this is even too much. Maybe you want to do it a little bit less, right? I don't know. You do it however you'd like. Maybe you want to rotate it more whenever it's even and less when it's odd, right? Well, we see what we get, but right, if I were to do like something like this, then we would see it more, right? So we can see some kind of pattern here, right? So if I were to make it this, maybe 20 and do up to maybe 2,000, right? Right, we're starting to see some sort of pattern here, right? So you can play around with it. Hopefully you find something you like doing this. Maybe this is a bit too low, maybe here this is fine, this is better. All right, we're seeing it a little bit sharper. So this looks just like noise, but it might not be, right? There might be some type of pattern behind it that we just cannot see because we don't have enough, right? let me do half pi instead of quarter pi, right? So we can see what does that give us, right? So this is a bit messy, but hopefully you have fun. Maybe with lines, it gives out the pattern even more. But yeah, so this function is a whole Collatz conjecture. So hopefully you have fun with it. Play around with it. Let me know what you do with it in the comment section below, and see you in the next one.